Hello, this is John from caveofprogramming.com, and in this video we're going to take a look at configuring and training a basic neural network in Java. And to do this I'm going to be using Deeplearning4j. For my IDE I'm going to be using the free IntelliJ IDEA Community Edition. I find it works a little bit better out of the box for some things than, for example, Eclipse, but you could also use Eclipse or your favourite IDE. So let's fire up IntelliJ IDEA and then create a new project. The important thing here is you need to have Java selected, and I'm going to use Maven for the build system. I'm going to be using Maven to pull in the dependencies that we need. Let's give this project a name. I'll just call it Neural Net and click Create. Now let's check the source folder here and go into main Java. If there's anything in there you can just delete it by selecting it and hitting the backspace key. I'm going to create a new package in this Java folder, so I'll right click and go to New Package. Since my website's caveofprogramming.com, I'm just going to call this package Cave. Our project's going to consist of just one file, and I'm going to show you the simplest possible example of configuring and training a neural network that I can come up with. Let's right click in there and go to New Java Class, and I'll just call this App. Hit return, and there we go. So I'm going to configure and train a neural network to just give us the same output as exclusive OR. This is going to be massive overkill for this particular problem, but once you see how to configure and train a network, you'll be able to adapt it to much more complex problems, and even to answer questions that will be hard to answer by any other method. Although the program we're going to look at will be very simple, you wouldn't have to change it all that much, for example to do basic image recognition. So in here I'm just going to have a main method. Let's expand the work area a bit by clicking this icon in the top left. And the first thing that we need is some data to represent the input and output to the network. But before I can add that, I need to add my dependencies. So I'm going to click on pom.xml here. So here we've got a pair of project tags, and there are some other tags within that. And what I want to do here is add a section called dependencies. So we need the opening and close dependencies tags here. And within here I can list the dependencies that I want, the things that I want to be downloaded and brought into my project. So I'm going to go to a search engine and search for Maven repository. That ought to do it. And we'll find this mvnrepository.com site, and in there I'm going to search for Deeplearning4j-core. So this is the basic API that we're going to be using to create and train a neural network. Here it is, and I'm just going to click on it, and let's pick the latest version here. And if I scroll down, that's what I need to add to my pom.xml. I'll just click it and it says copied to clipboard. And then if I go back to IntelliJ IDEA, I can just paste that between the dependencies tag. We need one other dependency. So if I go back to this website, and here I'm going to search for nd4j-native-platform. So this is what we need, and I'll just pick the latest version of that. Copy the dependency, go back to IDEA, and just paste it in right under the other. Machine learning with neural networks depends heavily on doing calculations in linear mathematics, basically. You could call it matrix multiplication or tensor multiplication, and that's what ND4J handles. This particular native platform version contains optimized native code that are going to do those calculations efficiently on my machine. One of the reasons for the explosion in AI these days has been that people realized, I think sometime around 2005, that it was possible to do these calculations on GPUs, on graphics cards. And you can get a version of this that can do that. But I'm just going to stick with this for now. So let's make sure that's saved. And then I'm going to click the icon in the top left, and I'm going to right click my project and go to Maven. That's right at the bottom of this menu. I think it's off the recording area, but never mind. I'm going to go to Maven and Sync Project. And that's actually going to download these dependencies. I've got a bit of a warning here. It's just warning about vulnerabilities, but that's not my problem to fix. and hopefully those will be fixed eventually, or maybe they don't matter, I don't know. If we look at external libraries now, and if you scroll through that, you'll be able to see, hopefully, that it has downloaded your dependencies. You can see ND4j there, and here you can see Deeplearning4j. So let's close this Project Explorer and close pom.xml. Now we've done what we needed to do, we've got the jars that we need, and we can write the code. You probably could just download the jar files and include those in your class path instead of using Maven or Gradle, but using a build system like Maven does simplify the task. If you do want to try downloading the jars, you can just download them from the Maven repository site. So first let's create some input data. I'm going to use var because I'm using a really recent version of Java. I think it's Java 24 here, the open source version. So I'll say var, let's call it input, equals nd4j.create. Now both my input and output data is going to be supplied as two-dimensional double arrays. First let's click import class on this, and then I can create here a new double two-dimensional array, and I can initialize this right here. Let's put some space in there to make it look a bit nicer. So I'm going to have just 4 samples in my input. That is, I'm going to have 4 pieces of data. And for each of those 4 pieces of data, I'm going to have an output, so a total of 4 outputs, representing what I want the neural network to produce when the input data is presented to it. So here, to start with, I'm going to have the values 0, 0. That's one sample from the input data. Let's duplicate that 3 times. I'm also going to have 1, 0, 0, 1 and 1, 1. That's all of our input data. So obviously this is very minimal, but it wouldn't be much extra work at all to present a neural network with, for example, a training set of images or whatever. Let's select that and just duplicate it, and I'm going to create my output in the same way. I'll call this labels, which is a terminology that's often used with neural networks. This is going to be the output data of my neural network. Now in the case that I present the neural network with 0, 0, I want it to produce the output 0. If I present it with 1, 0, I want it to produce the output 1. Same for 0, 1, that's also going to produce 1. And I want it to produce 0 if I present it with 1, 1. So this pattern is what we call exclusive OR. And obviously I could do this in one line in Java, but this is about the simplest, vaguely interesting example I could come up with of training a neural network. So now I'm going to combine those into a data set. So I'll say var data set equals data set, and we just pass that the input and the labels. Oh yeah, and I need to remember to have a capital S there. And it would help if I put new in as well. Okay, let's hover over that and go to import class. And yeah, I want this dataset class from ND4j. Now we can create configuration for our neural network. So let's say var conf equals, and I want to use new neural net configuration dot builder, like this. Let's hover over that and import the class. So the actual class we're creating here is called builder, but it's a field of neural net configuration. And the way this works is that you chain methods to this just with a dot syntax. And at the end you call build. So we're going to have a bunch of different things down here, and after we've finished specifying them, we're going to put build on the end like that. And this build method also just returns a neural net configuration, like builder itself. Neural nets conceptually consist typically of layers of neurons which are all densely interconnected with each other. Every neuron multiplies its inputs by weights, then sums them together, adds them all together, and runs them through a nonlinear activation function. So what we need to specify here to start with is a way to change the weights in order to train the network. And we do that by writing .updata, and here I'm going to write new SGD. That's short for stochastic gradient descent, which is a common method of training neural networks. Let's click Import Class, and I can specify a learning rate here, and that affects how much the weights are adjusted by every time we repeatedly present the neural network with the input data and the desired output. So here I'm going to specify just 0.1, and you can play around with that. Next we need some layers, so I'm going to go above here, and I'm going to say var, let's call this layer 0 equals dense layer dot builder. And I need to put new in there, which I keep forgetting. So here we're basically creating again a class called builder, but this time it's the builder that's a field of dense layer here. And again, we're going to specify some options, and at the end we're going to call the build method. So the same pattern as when we create the configuration, and we're going to use this layer in building up our configuration. So I don't need to specify much here, only really 3 things. I need to specify the number of inputs with .n_in, and that's just going to depend on how many values are in each data sample in my input, and the answer is 2. There's going to be 2 in every data sample, so I put 2 here. Then there's a question of the output. So you can kind of think of this layer as being the interconnections between the input layer of neurons and a middle sort of hidden layer of neurons. And we're also going to have after that an output layer of neurons. The size of the hidden layer is something you can play around with. Generally you want it to be as small as possible, because if it's bigger you're going to need to train the network for longer. But if you make it too small, then it's not going to be able to learn the data that you're presenting to it. Now in this case we've got a very simple task which can be handled with a middle hidden layer of only 2 neurons. So I'm going to say that the output from this layer with n_out has a size of 2. Finally, we need to specify that activation function, because the inputs are going to be multiplied by weights and run through some kind of non-linear function. And a very common, I think the most common activation function to use is called ReLU. So I'm going to use that. Let's say .activation and then activation.ReLU. ReLU is a really simple non-linear function. It takes the input, and if the input is less than 0, it returns 0. If it's greater than 0, then the output of it just becomes the input unchanged. So that's about as simple as you could possibly get for a non-linear function. It has to be non-linear for the neural network to work. And this is so simple you almost wouldn't think that it would work, but in fact it does work extremely well. So we're finished now with our first layer. We need one more layer here. Let's copy this because it's going to be similar and paste it underneath. And I'm going to call this layer 1. Now this time, since this is going to be the output layer, instead of dense layer, I'm going to use output layer.builder. Let's import the class for that. The reason this is called dense layer is it just refers to the dense interconnections between different layers of neurons. And this is the output layer that actually produces the output. So it's going to have 2 inputs because this has 2 outputs. They need to connect together. And the number of outputs this has will be determined by how many values we have in each sample of our output data, the desired data that we want this to produce. And this just has 1 value per sample. So let's just put 1 here. Now for the activation, we don't want to use ReLU here because we actually want this to produce a value between 0 and 1. So if it produces a value closer to 0, we'll consider it to have basically said that the output should be 0. And if it's closer to 1, we'll consider it to be 1. I can achieve that using a function called sigmoid. Sigmoid function has an output that goes from 0 to 1, which is perfect. We also need a thing called a loss function. The purpose of the loss function is to compare the output of the network with the desired output of the network, which we specified here. It returns a single number, and the closer that number is to 0, the better the prediction of the network is considered to be. So I'm going to say here, loss function dot It's actually lossfunctions.lossfunction.xent. This is actually called binary cross-entropy. It's a kind of categorical cross-entropy. Incidentally, I know there are a lot of different terms and concepts going on here. I do actually have an entire course that covers all this stuff, and I'll mention that again at the end of the video. Binary cross-entropy here is going to work well with my sigmoid activation. So now we've got our two layers. Conceptually, we've got three layers of neurons. We've got an input layer of neurons. We've got a middle hidden layer of neurons, which has two neurons in it. And we've got an output layer of a single neuron. And these kind of represent the interconnections between them, or that's how I like to think of it. So if we now go to our neural net configuration, here I can say .list to specify that we're about to give a list of layers. And here I can say .layer, and the 0th layer is going to be my layer 0. And then we'll have .layer, and this is going to be layer 1, and that's going to be the layer 1 that I've already created. Now our configuration is complete. Now I can go ahead and create the actual neural network model. So let's say var model, I'll call it, equals multi-layer network. And I need to put new there, which I keep forgetting. Been doing some Kotlin recently and it doesn't have that keyword in it. Let's hover over this and go to import class. We need to specify our configuration when we create this. And we mustn't forget also to call model.init to initialize it. We're almost done now. So now what I need to do is I need to present the input and the output at the same time to it, repeatedly. Every time we do that is called an epoch. So we want to have multiple epochs. In a single epoch, we present all the input data and at the same time the corresponding outputs. And in this case, we're just trying to get the neural network, for example, to spit out 1 when it receives this. But of course, with a more complex task, the neural network is capable of generalizing and even spitting out an appropriate output for data that it hasn't even seen before, if there's some kind of pattern in the data. So let's say down here, for int epoch equals 0, epoch less than, and again this is something else you can play around with. Let's try 1,000 epochs and epoch plus plus. For every epoch we're just going to do model.fit and we're going to present the data set to it, so including the input and output data. Now just so that we can see how it's doing as we go along, let's, every time we do an epoch, present the input data to the model and see what predictions it makes. Let's say var predicted equals model.output, and we present all of the input. And that's going to spit out predictions for all of our inputs. We wouldn't want to do this if we were working with a data set of any great size at all. But here it's a really small data set, so I can just do this. And I'm going to do system.out.println predicted so that we can see that as it runs. Okay, so this is the entire thing. Hopefully I've not forgotten anything here. And you can see that it's really not very much code at all. Let's actually try running it. So with Java 24 and this API, I do see some warnings about, vulnerabilities and accessing things that might be deprecated, but I'm not going to worry about those. Hopefully they will be fixed in the future. Let's just click the run button at the top. And here you can see the predictions that it's made. And hopefully they should improve as we go through each epoch. Let's take a look at the last prediction. So what we ideally want it to predict, if we look at the output data, we want it to come out with 0, 1, 1, 0. And it's come out with 0.3, 0.9, basically 0.9 and 0.06. So if we were going to round these off, we would indeed get 0, 1, 1, 0. And you can probably get better results than this by just playing around with this and tweaking it. You can change the learning rate, the activation functions, the number of hidden layers, the size of the hidden layer, the number of epochs, and so on. And what we could do now is we could save that model now that it's trained, and we could use it in a completely different Java program. If you want more tips on how to alter your model, how to improve it, how to make it do something more interesting. Don't forget you can always use an AI chatbot like Microsoft Copilot. At the moment at least, you don't even have to register for this. You just go to the web page and type in your code request or your question and it answers it pretty well. And if you're interested in a much deeper and more extensive explanation of how neural networks work, I have a course where I show you how to build a neural network completely from scratch in Java. This assumes only basic Java knowledge and basic algebra knowledge, and it teaches you all the mathematics and the concepts that you need to understand how neural networks work. We go through the necessary linear algebra, we talk about information theory and cross-entropy, the relevant calculus and backpropagation, and I demonstrate that to you practically in Java, and so on. And we do all this just using basic Java code, and at the end we have a neural network that can do basic image recognition. Do check that out, the link's in the description. And if you're watching this video when it first comes out, this course is going to be on sale for the next 5 days. Just click the link in the description. Thank you so much. That's it for this video, and until next time, happy coding.